So children, some important questions in periodic classification we will discuss children. Important questions in periodic classification. Okay, these are your textbook exercise only children. I am doing textbook exercise. Okay, at the last first question children, they are asking first question, which of the following statement is not a correct statement about the trends when going from left to right? First one, I will read four characters children, you tell me children whether it's correct or not. First one, elements become less metallic as you go from left to right. Elements become less
True.
metallic because metallic character
It
decreases in
decreases
period.
along.
It is true. Metallic character decreases. Metallic character decreases in period. We know it is true. Metallic character decreases from left to right. Number of valence electrons increases. First group will have 1, second group
True.
will have 2, 13th group 3, 14th group 4, 5, 6, 7, 18th group will have 8. Valence electrons increases. True.
True.
The atoms lose their electrons easily. Losing electrons is called electropositivity.
Electropositive.
Losing electrons is called electropositivity. As you go from left to right, metallic character is decreasing. Means electropositivity is decreasing. Means losing electrons becomes difficult. Losing electrons become difficult. If they are losing electrons easily, it is more metallic. But metallic character is decreasing. What he said, the atoms lose their electrons easily. No, false.
False.
False. Okay. The oxides become more acidic. Left side is
True.
metals, right side is non-metals. Non-metals are
Yes, sir.
acidic.
Acid.
Acidic.
Non-metals are acidic. Yes, these are basic. Basic is turning into acidic. As you go from left to right, basic are becoming acidic. It is also true. You should analyze like this in the exam, children. Be careful, children. Element X forms chloride with the formula XCl2. Element X forms chloride with XCl2. Sodium, they have given four elements children: sodium, magnesium, aluminium, silicon. This X resembles which element is asking?
Magnesium.
Magnesium, sir.
Magnesium. 2 will go here
Magnesium.
children. X plus 2. Plus 2 means it is giving 2 electrons. Plus 2 giving 2 electrons, it is a metal, means second group elements. Who are the second group elements? Beryllium, magnesium, calcium, strontium, barium, radium. So magnesium is, it is resembling because plus 2 means second group elements. Minus 2 means 16th group elements. Plus 2 means second group elements. Minus 2 means 16th group elements, children. 16th group elements. So be careful, children, when you are doing the questions. Third question, children. Which element has two shells? Which element has two shells with completely filled electrons? 2, 8.
Neon.
Neon. Next question. Who is having electronic configuration 2, 8, 2?
Calcium.
Magnesium.
Oh, sorry.
Okay. The total number of 3 shells are there. Total number of 3 shells are there. Here 4 are there means what does it mean? Here 4 are there means what does it mean?
Silicon.
Already here 2 and 8 have been over. So here it is 4. So it is 14. 14 means who is that, children?
Silicon.
Silicon belongs to which group? 14th group. Carbon, silicon, germanium. Okay. Next, a total number of 2 shells with 3 in outermost. Here 3 are there means compulsory here 2 should be there. 2 plus 3, 5. 5 is boron.
Boron.
Boron belongs to which group? 13th group. Boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, thallium. Twice as many electrons in the second shell. Here 2. Twice of it is 4. 6. 6 means who, children? Carbon. Carbon belongs to which group? 14th
14th.
group. Belongs to which period? Second period. Belongs to which period? Second period. Belongs to which period?
Third.
Third period. 3 shells are there, so belongs to third period. Belongs to which period?
Third.
Third.
Third period. And second group. 14th group. Belongs to which period?
Second.
period.
Belongs to which group?
18th group.
18th group. Belongs to 18th group. You should be very, very careful with the process of this, children. What property do all elements in the same column of periodic table as boron have? Children, as boron have means, children, Boron atomic number is 5, 2 comma 3. Outermost electrons are 3 electrons are there. Outermost electrons, how many are there? 3. So they belongs to which group, children? 13th group.
13.
13th group element will have 13th group elements will have 3 electrons in outermost shell. 13th group elements will have 3 electrons in outermost shell. Who are there? Boron, aluminium, gallium, indium, thallium. In exam we should write down, so no need. What is the common feature is asking. Common feature is they all have 3 electrons in their outermost shell. You should write. What is the common feature? They all have 3 electrons in outermost shell. What is the common feature? They all have 3 electrons in outermost shell, and valency they give 3 electrons to attain stability plus 3. Okay, what property do all elements in same group of periodic table as fluorine have? Fluorine is 9, children. 9 means 2 comma 7. Outermost 7. Outermost 7 means which group, children? 17th group.
17th.
What are the 17th group elements? Fluorine, chlorine, bromine,
bromine,
iodine, acetylene. Okay, and what is the common for all these group elements? They have 7 electrons in outermost shell, and minus 1 is the valency. Okay, what is the common for all of these elements? Their outermost shell has 7 electrons, minus 1 is the valency. They are non-metals. What are they called? 17 group elements are called halogens. Why they are called halogens? Because these salts are found in seawater. These salts are found in seawater. These salts are found in seawater. Okay, children. 17th group elements: fluorine, chlorine, bromine, iodine, acetylene. Are you listening, children? I don't know how many of you slept already. An atom has electronic configuration 2, 8, 7. 2, 8, 7. Okay, children. What is the atomic number of this element? 17.
17.
Atomic number of element is 17. To which of the following elements would it be chemically similar? They gave children nitrogen. Children, they gave nitrogen 7, fluorine 9, phosphorus 15, and argon 18. Okay, argon 18.
So fluorine.
Fluorine, sir.
Yeah, tell me configurations, children, please. Tell me configurations. 2,
2,
2,
5.
5, 2,
2,
7,
7.
2, 8,
8,
5, 2, 8, 8.
2, 8. This is having 7. This is who is having 7?
Fluorine.
So it chemically resembles fluorine. You should say it chemically resembles fluorine. Why means here? This also you should show in exam. This also you should show. And because they both have 7 electrons, they belong to which group? 17th group.
17th group.
Group elements are non-metals with valency -1. And famously they are called halogens because they form sea salts. One below each other. You should write whether they ask or not. How much ever you know, that much ever you should write. But first line you should write it resembles fluorine. Then you should write all these justifications. Okay, children, how much ever possible, that many justifications you write, children, try to impress the examiner, children. Next question. Okay, children, they are giving like this, children. Group 18 they have given, group 17 they have given, children. In group, 16, children, this is 16. Okay, group 16 and group 17 are given. Here dash dash, here dash A, and here dash dash elements. These are B, C elements they have given. This is group 16, group 17, children. This is one period, this is one period, this is A is there, this is okay. I will write neatly, children. I will write neatly. I'm sorry. 16th group, 17th group. No elements in the first period. In second period they have given this and A. In third period also no elements. In fourth period B and C are given like this. B and C. First question. Whether A is metal or non-metal. This is the first question.
Non-metal.
Non-metal, sir.
A is non-metal, compulsory underline. Why it is non-metal?
It gains
takes one electron to attain stability.
stability.
Okay, and charge is -1. Charge is -1. It takes one electron. Taking electron is a property of non-metal. This you should write one below each other in exam. Not like this. Because I don't have place, I am writing like this. You should write non-metal. It takes one electron to attain stability. Valency is -1. As they take electron, it is a non-metal. As they take electron, it is non-metal. As they take electron, it is non-metal. Next, state whether C is reactive or A is reactive. Among A and C, which is more reactive? This is a non-metals. Non-metallic character down the group decreases. Non-metallic character down the group decreases. Non-metallic character down the group decreases. So A is more reactive than C. what you will say, now A is more reactive than C, you should write in the first line like this. Down the group, non-metallic character decreases. When non-metallic character decreases, this is good non-metal, this is least non-metal. Therefore, A is non-metallic character only reactivity, children. For non-metals, non-metallic character is only reactivity. For non-metals, non-metallic character is reactivity, and for metals, metallic character is reactivity. Okay, children. And next one, which is larger, B or C? Which is bigger in size?
B.
B is bigger in size because along period atomic
Atomic
size
size
decreases. You have
decreases.
tried B is bigger than C like this, and down you should write atomic size decreases in a period. Atomic size decrease in period. Why? Because electrons increases, nuclear attraction power increases, electron tries to come closer, atomic size decreases. Electron tries to come closer, atomic size decreases. Electron tries to come closer, atomic size decreases. You should write a good reason, children. Okay. Next question is this. What type of cation or anions are formed by A? A will form what, children? A will form anion. In the first line you should write A will form anion. Anion means negative ion. Why they are forming negative ion? They take electron to attain stability. And therefore, because they are taking electron, they are non-metals. Non-metals form anions like that. Maximum you should justify, children. Maximum. If you want, you give an example also, no problem, children. How much ever possible, that much you have to justify your answer, children. You see that they should not get any feeling that you have copied answer from your friends. Maximum you try to convince with your answers. Okay, children. Next one. Next one. Seventh question, children. Seventh question I am discussing here. Nitrogen atomic number 7. Phosphorus atomic number 15. Phosphorus is 15. Okay. Write the electronic configuration. Which is more? What is the configuration of this? 2,
2,
5.
5.
2, 5.
2, 8,
8, 5.
Which is more electronegative? Down the group. This is down the group. Electronegativity decreases. Down the group, electronegativity decreases. Nitrogen is more than phosphorus. Down the group, electronegativity decreases. Nitrogen is more electronegative than phosphorus. Why down the group electronegativity decreases?
The non-metallic character decreases.
Size increases. Electron goes far. Electron goes far from nucleus. Nuclear attraction power decreases. When nuclear attraction power decreases, no one is there to attract electrons. No one is there to attract electrons. Electronegativity decreases. Electronegativity decreases down the group. Electronegativity is nothing but non-metallic character. Non-metallic character decreases. Why? Because size is increasing. When size is increasing, electrons, nucleus is here, but they are somewhere. Who will attract them? If nucleus is very far, who will attract them? Here means they can easily attract because they are very small. But here, who will attract them? No one is there to attract. Therefore, electronegativity decreases down the group. Next, how does electronic configuration element? Children, how does electronic configuration relate to the element? Outermost electrons, valence electrons is equal to
Group number.
And number of shells
Cells
is equal
is
to
period number.
number of shells is equal to period number. One example will give. Suppose magnesium is there. 2, 8, 2. So outermost 2 is there, second group, and 3 shells are there, third period. 3 shells are there, third period. Almost 2 are there, so second group. Next. Children, in modern periodic table, calcium 20, children, calcium 20, calcium is 20, is surrounded by some of the elements like 12, 19, 21, 38. It represents which elements? 20 configuration, 2, 8, 8, 2. 12 configuration,
2, 8, 2.
19 configuration,
2, 8, 9.
21 configuration, 2, 8, 8, 3. 38 configuration, children, 2, 8, 8, 18.
18.
How much, children? 18, 18, 26, 26, 34, 35, 36, 2. Okay, children. So calcium represents which one, children? 12 and 38. 12 and 38. Calcium represents 12 and 38. Because outermost 2 electrons are there. Calcium represents 12 and 38. Calcium outermost 2, no, children. So calcium represents 12 and 38 because they also have outermost 2 electrons. Compare modern periodic table with the Mendeleev's periodic table. Compare modern periodic table with Mendeleev's periodic table. Modern periodic table, Mendeleev's periodic table. Modern periodic table is based on
Atomic
number.
number.
Mendeleev's periodic table is based on
Atomic weight.
mass number or atomic weight. In modern periodic table, 18 groups are there, 7 periods are there. Here 8 groups are there, 6 periods are there. Okay children, please mute your audio children. In Mendeleev's periodic table, inversion of atomic weights occurred. Do you remember children? And here it is rectified. Why it is rectified? Because elements are arranged in increasing order of their atomic number. He did not keep isotopes. Isotopes did not find place. Here all isotopes are kept in one place. Why? Because they have same atomic number. All isotopes are kept in one place in modern periodic table. Why? Because they have same atomic number. Isotopes are kept in same place. In Mendeleev's periodic table, isotopes did not find place. Okay children, so these are some of the famous differences between modern periodic table and Mendeleev's periodic table. Be careful children, here inversion occurred, here it was rectified. Here isotopes did not find, here isotopes also rectified. Like this, this is the exercise in your textbook children, last exercise in periodic classification. So anyone have any doubts children?